All right, so the problem that each of you had was either solving this polynomial equation or you had to solve this one. But regardless of which one you had, in both situations, you were going to do this, you're going to solve this polynomial equation by using factoring by grouping. And basically, what you had to do was, first of all, you had to make sure that this polynomial equation was in standard form. So you needed 0 on the other side, which you already had in both cases. 0 was on the other side. And you also needed to make sure it's in descending order. Now, usually what happens when you use this approach is that you can group the first two and the last two. And in the first two and the last two, when you factor out the GCF, the greatest common factor, then what you're going to be left with at this step right here will have a common factor. And the same thing here. You would either, you would have to group the first two and then the last two. So if we go back to this one, notice that in the first group, the greatest common factor is x squared. So I'm going to go ahead and factor out an x squared. And so when you do that, you're going to get x squared times, and then basically you're going to say x squared, so using the distributive property, x squared times what is going to be x cubed, and so that will be x. And then x squared times what term is going to be a negative 3x squared, and that would just be a negative 3. Okay, so notice that this group right here can be written as this group, or as this set of factors. So the GCF is x squared, and so I can factor these two terms here, this group, as x squared times x minus 3. Now hopefully this factor right here will have x minus 3 as a common factor. So in this case, notice that I can factor out the greatest common factor of 9. 9 goes into 9x, and 9 goes into negative 27 evenly. So I'm going to go ahead and say plus 9 times, and then when I factor out a 9 from this term, you have x, because 9 times x is 9x. And then from this one, you'll say 9 times a negative 3 is a negative 27. And then don't forget to say equals 0. And then at this point, notice that these two groups right here, these two groups, they have an x minus 3 in common. So I'm going to go ahead and factor out an x minus 3. You have to show that. You have to say x minus 3 times, and then when you take out an x minus 3 from this term, you're left with x squared. And then when you factor out an x minus 3 from this term, you're left with a positive 9. So that you have to show. Then I'm going to use the zero factor property. So remember, the zero factor property says that when you have two or more factors whose product is 0, one of those has to be 0. So you're going to say x minus 3 equals 0, x squared plus 9 equals 0. So notice I went from a cubic equation to a linear and a quadratic. A linear equation, that's easy to solve for here. So x would have to equal 3. So there's one of your solutions. Over here, notice it's a quadratic equation. It is not the difference of two squares. This is the sum of two squares, which cannot be factored over the integers. So what we had to do is notice that there's no x term. There's an x squared and a constant. So what we're going to do here is we're going to bring the 9 to the other side. So we're going to get x squared by itself. And when I do that, I'm going to get x squared equal a negative 9. Then to get x by itself, right now I'm squaring. The opposite of squaring is to take the square root. But remember, one of the properties you learned was that when you take the square root of both sides of an equation, you're going to end up with a plus and a minus part. And so then the square root and the square undo each other, so you're left with x equal plus or minus the square root of a negative 9. Now remember, the square root of a negative 9 is not a real number, but you learned about imaginary numbers. You learned about the fact that the square root of a negative 1 is equal to the imaginary unit I. And so the square root of a negative 9 then would be, don't forget the plus or minus, would be plus or minus, and then remember the square root of 9 is just 3. So this would be plus or minus 3i. And so those are your solutions. There are 3 of them. So your solutions would be x equal 3, 3i, and then negative 3i. So you have 3 solutions. One of them is a real solution, the other two are imaginary. So there's the work you had to show, and then those are your solutions. Remember, you have to show all the work to get all points. Okay, now the next one, if you had this one, the same idea. Notice that the first group have the greatest common factor being x squared, just like the previous one. And in this case, you're going to say x squared times x is x cubed, and then x squared times a negative 2 is a negative 2x squared. From this group, notice I can factor out a positive 16. That's the greatest common factor. So you can say plus 16 times, and when you do that, you're going to also get x minus 2, which is what you really wanted, because this is an x minus 2. You really wanted this to be an x minus 2. Don't forget to say equals 0. Now from these two groups here, notice that they have an x minus 2 in common. So I'm going to factor out the x minus 2. And then you're going to be left with, when you take out the x minus 2 from that first group, you're left with x squared. And then from the second group, you're left with a positive 16. And you're going to say equals 0. So notice it's to show. Then, just like the previous problem, you can use a zero factor property. So you have two factors here whose product is 0. So you're going to set each one equal to 0. And then you're going to solve each of those individual equations. So just like the previous one, I went from a cubic equation to a linear and a quadratic. The linear one is easy to solve for. So x equals 2. There's one of your solutions. This is your real solution. Over here, just like the previous one, to solve for x, you cannot factor this because that's the sum of two squares. But to solve for it, what you're going to do is you're going to get x squared by itself. So you're going to x squared equals negative 17. And then the opposite of squaring is to take the square root. So we'll go ahead and rewrite this over. And you're going to take the square root of both sides. So we get that plus or minus. And remember, the square root of a negative 16, I can write as the square root of a negative 1 times the square root of 16. The square root of negative 1 is I. The square root of 16 is 4. So this becomes 4i. But your solutions are, remember, the plus or minus. So you're going to say x equals plus or minus 4i. And so for this particular problem, your solutions would be, if you were to write them all out, you're going to say x equals 2, x equals 4i, and then x equals a negative 4i. And so that's it. So notice some of you had this one to do, and then some of you had this one. All right, well, anyway, so that is how you solve those problems. That's the work I had to see to get all points.